Dottori, tutto a post. Welcome back to a new video. And today I'm going to show a little bit of updates for March 2024 about Sane C++ libraries. What is Sane C++ libraries? Sane C++ libraries is this project that you can find on GitHub where I'm creating a set of C++ platform abstraction libraries for macOS, Windows, and Linux with fast compile times. They are bloat-free, they are simple and readable and easy to integrate, and there is no use of the C++ standard library or exception or runtime type identification. And in general, there are no third-party dependencies so far. Basically, we're just using operating system APIs. So let's go back to what we're going to show today. So I will mainly be going through the contents of this blog post, which is linked in from the README homepage. This is the March 2024 update, and you can find it also in the documentation. So the big new thing that has been added this month to the project is this SC tools, which we are going to be diving into and what they really are. So Sane C++ tools are basically just simple development tools for automating tasks that we need to carry on day-to-day development. But instead of creating them as shell scripts or creating them as Python or JavaScript scripts, we are just going to create them as C++ scripts using Sane C++ libraries. So something like this was already existing in the past. It was the build system, the, let's say, handmade build system called SC-build that was, let's say, compiling a file with the definition in C++, the C++ definition of the project, and this compiled file was able to generate all of the project. So all of this got somehow generalized into a file that is now made of a bootstrap called just SC for Sane C++, that is invoking this tools batch or shell file. And this allows us to execute any of these scripts, if we want to call them like this, but at the end of the day, they are just programs. So let's try. Let's say I'm going to do an SC build, which is a replacement for the old build SC build command. Let's try it. Okay, we see that it's creating something. It's compiling SC-build.cpp, which is this file. It's compiling tools.cpp, which is this file. And we see that this file is including the bindings cpp sc.cpp, which, as you can see, is just a unity build of the entire library. So the thing here is we can supply a simple file, which I can even just explicitly pass in like tools sc-build.cpp, and this is going to be compiled. This compiled file will go into this tools. We are on macOS, so this will go on the Darwin subdirectory, and this is just an executable. We can see the intermediate file created here, which are the object file for the script, and the tools, which includes the entire library plus a little bit of support code. And as you can see also, if I'm not modifying the tool, this is not going to be recompiled. It's just executing the tool. Let's see, the tool is just doing, it's checking for some arguments, and depending on the arguments, it's filling some data structures. In the specific case, this is using the build library, which you can find in libraries build, to generate the projects for Makefile, Visual Studio, and Xcode. But this is just one of the tools. And now the tools can have like a default action. The default action for the SC build task is called configure, which is this one. So I can even say SC tools SC build configure, and this is what's happening, but I can even say compile. And when I say compile, it, depending on the platform, it will choose the correct command to compile the program, and it will compile the program. It sounds pretty not so smart to say, but that's what it's being done by this script. And you can see that it just generates the intermediates files and the outputs in this case in macOS. I'm on ARM64. I'm using make as a build system, clang as a compiler, and this is the debug configuration. So the folder name is like including all of the things that are identifying my build. And by the way, these are specified by the SC-build file itself, which is using those sub variables that get substituted and replaced during the compilation. Now, first of all, this works on all supported platforms. So now I can start, for example, the VM, if I can find it, not this one. I want the Linux Ubuntu VM. Can I start it? Control Center, yes. Oh, it's already started. So I can just go on Linux, connecting in my local Linux on SSH. And if I do the same, in this case sc.sh, I can just say build for tools that are in the tools subdirectory. They are just special. And I will get my tool compiled for Linux in this case and executed. And we can see this folder is shared with the macOS host, so it's basically the same directory. Now I have a Linux subdirectory with an executable build for Linux, and now it's regenerating the project. And I can even compile now this one, so I can say sc what is build compile. And now I'm compiling, but this time I'm on Linux. So I have a Linux ARM64 make GCC debug folder, and the same for the output. So this is cool. I mean, just for the sake of it, we can try doing it the same on Windows using my ARM machine. But I guess you understand that this is, as the Sane C library is a multi-platform first project, this works also on Windows. So I can say SC, there's a batch file build. So this is configuring the build. On Windows, this is a little bit slower, also because I just booted the virtual machine. But at some point, this is compiling the tools and generating the projects. And as you can see, this folder, which is again the same folder mounted on Linux and macOS, has now a Windows subdirectory with an executable that, once it's executed, it will generate the project in this case. So we generated them 3 times, and I can compile. And this is invoking MS-build to build the generated project. So this is all pretty good so far. Now, let's see what you can see this finishing compiling, but this will work until the end. What other tools have been added? The second tool that has been added is the SC package tool, and the SC package tool is basically doing, like a poor man's package manager. So far, it's not even declarative. It's mostly imperative. So it's just a program that is doing a bunch of stuff. Let's try it first of all. So sc.sh package, and that's it. I'll just use this one. So this is first thing you should see is that it's compiling only SC package, not anymore the tools, because the tools now are for the macOS. I'm on Linux. Sorry. On Linux, the tools are already caching are reusing the compiled tools object file. So as you can see, compiling the scripts is really fast because the headers of Sane C libraries are designed to be very fast when included. They are not using any crazy template meta programming or any technique like that that is slowing down the compile time. So this is booting pretty fast, and it started downloading. This is the official copy of LLVM and CLang and version 15 dot something. Now it's extracting it. So basically it has been downloading this distribution XZ file. Now with the XZ affair going on these days, this is probably a great idea, but I think macOS should not be affected, because I think the problem with the backdoor that has been added to the XZ compression is mainly affecting Linux. But by the way, so we are extracting it into this extracted folder, and once the tool is extracted, before doing that, we are checking the MD5 using Sane C libraries, using the hashing library, which you can find here. Hashing as an MD5, yes, option, type MD5. And after checking that the MD5 matches what we are looking for, this is being extracted, and all of these operations, both the download and the extraction, are just done using tools already available on the operating system. So the compression part is not integrated into Sane C library, but I'm just using proper process right direction and process spawning to achieve all of these. Once the folder is completely extracted, it's going to be symlinked into a directory called packages, where I will have symlink to my, in this case, the CLang binaries. Now, I could be doing the same for macOS, for example, and all of these will just live happily side by side. So I can say sc.sh package. It's compiling package. Now I already started downloading. So the program, is spawning, I think, a CURL process that is downloading what's necessary and doing what's supposed to be doing. I should probably pause or stop the Windows VM, because this is otherwise a little bit heavy for my system. Let me pause it or suspend it. Yes, even better. So it finished, yes. This is the Linux one. It just finished, and as you can see, there is a symbolic link in the packages, CLang, binaries, Linux, ARM64. I have my binaries directory. I plan to do many things with CLang, but for now, the main thing that I would like to be doing is just using the CLang format command to automatically format files in the repository, and also to make sure that people who would like to contribute to the project can just let's say format files as they are supposed to be formatted, because all of the formatting is being enforced into a CI step that checks if files are formatted properly using CLang format. So this works on Linux. This is now going on Mac, and I guess by now you understand that this is working also on Windows. So this is taking a little bit of time to download. Not sure why it takes so long, but I guess it's showing the point now. But I need this downloaded for. I need this downloaded to show what I want to show next. So let me try to restart it. This is typically taking a lot less time. Not sure why it takes. Yes, now it's going a lot faster. For some reason, it was downloading it from a very slow source. I mean, I could be replacing. I already have a copy of this package cache that I could be replacing. So one more thing to say about this package cache. So when you're extracting some packages, the source, let's say zip files in this case, are being saved into this package cache, and they are being extracted and symlinked here. but you will keep this cache forever. So if you want to get back your space, you can just delete it if you don't need them anymore. The system will just check before trying to reinstall a package if the tool that is being installed is functioning. So in this case, we are checking if C-length format can be invoked, if it's of the right version, and if it actually can format like a test file that we are adding into the test script. Oh, this is way too slow, so I think I'm going to stop it and move the package cache back to where it was. So yeah, let me try to do that. Move, I think I moved it here. Package cache, where is it? Yes, package cache into build. Yes. So now I have my package cache. If I do try sc.sh package, that should be instantaneous because this is checking the MD5. The MD5 matches and it's all good. So it's just recreating, in this case, the symbolic link. As you can see, I can delete the packages directory. I rerun the package and it's recreating the symlinks here. Once I have this installed, I can run my third tool, which is SC-format. And the SC-format is a lot simpler than the other two. It's basically running a number of C-length format processes. But let's say it's kind of similar to what you would do with a script like this, like, find all the files in a directory and on each one of them run C-length format or, dry run C-length format. But it's actually even a little bit smarter than that because I am creating number of processes with a maximum cap of 32 in this case. I mean, it's just an arbitrary number that I decided. And this is checking with this process limiter class, which it's very simple class, but you can give it a look. It's using the async IO library that is able to check for process exit notification. And it's checking as soon as one process it's exited, it will just spawn a new one. So we always have, in this case, up to 32 processes working on the files without ever, let's say, overcommitting or oversubscribing with an excessive number of processes. And so this is pretty cool. Actually, this is parameterized on the actual number of proper processors that are on the system. So even if this is run on a VM, it's not just trying to spawn 32 processes, but it will spawn as many as cores that are on the system. So all of this is also non-allocating because, as you can see, this has a reasonable, I mean, we can make it even, I don't know, higher, but still something that is a reasonable, maximum number of processes that could be monitored by the system, but we are parameterizing on the runtime number. And even here, when we are iterating for each file, we are using the file system iterator, and this is not allocating anything. It's just running through the directories and the files and calling a callback. And this callback is the one that spawns the process. So this is completely, let's say, useless in this regard. I mean, we don't really care how much we are allocating in a program like this, but nevertheless, this shows how these different libraries can really operate together, trying to create programs that are efficient and they are not like allocating like crazy all the time. I think this is one of the actual design constraints that have been put in place into the entire set of Sane C++ libraries. So let's give it a look. I mean, let's try to, I don't know, change the format of some files, and we can do SC format. So this is compiling SC format, executing it, and boom, it actually formatted not just this file, but the entire folder. I mean, I can change any other file I can change this SC-build file, rerun the format, and it will go back. So this is pretty cool. It's also looking for CLang formats that are on the system. In this case, it found one in Homebrew, but if it doesn't find one, it will call the SC package and use the one in the SC package. If I only knew, can I remove this from brew? Brew, remove LLVM at 15. Does it work? Okay, it's uninstalling it. So let's try to SC format again. So now you can see it doesn't find it anymore, and it's using the one included here. So I mean, I can try again. It still works. Yes. I've added a new feature, which is called basically another action, which is called check. If I do the check, it will return me an error invoking the CLang format, whatever is the check command set of flags. And we are using this in the CI to validate that someone is running code, is submitting code that is properly formatted. All of this brings us to how now the CI/CD files look, and they are pretty slick, because now you have CLang format, which is, you know, face. This is like the Linux runner. It will, before doing anything, check, you know, doing a format check. So if you are sending an MR, please make sure to run SC format, because then SC format check will run, and if your code is not formatted, it will fail. In this case, Linux is installing liburing, because some of the tests will run only if liburing is found, and it's running the build configure, which is what we have been running before, and build compile, which is what we have been running before. And it's just executing the generated project in the output folder that has a predictable name, because if we are on Linux and we are on an Intel machine, we are using make as a let's say build system, and using GCC as our compiler in debug configuration. That's where our executable will end up as per our instructions in the SC build file. Now, that being said, this is basically the covers the entire first part of the blog post. There are some, you know, additional reasons. So why am I doing this? You know, this is always, you know, a large portion of wheel reinvention, but even not considering that, I really think that this is something that allows to grow the library into something more you know, structured and more solid, because you create real tools with it, and this has been working. I mean, I can show you that many improvements have been done to the library, but I will do in a minute. I just wanted to talk a little bit about a couple of technical details, like on Windows to install this CLang format. As it was really not easy, because you need to unzip it using 7-zip, and even the 7-zip installer needs like another executable. So the SC package was not really easy to put together, because you have to download a file, check the MD5, use this one to extract another installer that has another MD5, and use that to extract the LLVM. I don't know why they made it the LLVM official binary distribution to be an executable file that requires admin privileges, but you know, we kind of made it. So now going back to the Sane C++ improvements, basically the process library got a pretty heavy, you know, facelift. Now it's a lot easier to use. You can see it synthesized here. You can just exec, you know, a process like this and capture its output, even in a string with a static buffer like this. So without allocating basically anything, you can launch a child process and wait sometime later for its exit signal. Or you can exec something and deciding if you want to be inheriting the standard out in your current process, and you can pass you can write something to the standard input. In this case, we are writing this child proc string to this grep process that we are spawning. So this will be the equivalent of this shell command. We can read process output using a pipe, for example, and this is how you can do it, just a few lines of code. And you can pipe multiple processes together really easily like this, and capture their output, composed output, very, very easily. So I suggest to give it a try. Of course, even I improved the documentation as well. So you can see it. I mean, you can go in the tools. Where is this? This is in the, where is it? Libraries. Sorry, I don't even know where I put things. Features, you can see all of, how you can use it. So the different modes are all explained here. So I've been expanding a little bit about this. And also I got a few very tricky OS specific failures. Like this was really hard, for example, on in some cases the key event backend for the async library was not catching properly the process notification. And this was only showing when you had a lot of processes, because I learned that on Linux, in some cases, process notifications are kind of being grouped together. Actually, no. This is another error. This is the error that is caused when processes are exiting way too fast. The one that I just described is this one, the merged sig-child by signal fd on ep.15 backend. Sorry for the confusion. So this is the process. SC-build now actually got capability of compiling specific configuration and architecture. And this is what you basically can achieve by trying to compile all of the supported OS and platforms. Actually, I don't have I do have, yes, Mac, Windows. Sorry, I do not have a Linux x86 VM, so that's the only configuration. You don't see it here, but all of the others, are here listed. You can see them, and this makes it very easy to keep basically the same folder mounted on different virtual machines, and develop in parallel on the code base mounted on multiple virtual machines, if this is what you're doing, because this is what I am doing. So this is cool. And also the SC Sync library got some improvements. One is the one that I already described, the bug with the process exit notification being grouped. So this is signal child. This is the signal you get when a child process is terminated on Linux, is finishing its life, it's exiting. And this was the way it was being handled was not correct before. Now it's correct. So we have been gaining a little bit of stability. So this is cool. SC file system got some addition, ability to create symbolic links, and creating checking links and so on. And this is very good. And always, SC string is one of the libraries. Every time I do something, I keep adding something, even minimal, like the casing parameter to appendix, and ability to check something in UTF-16, which is the native format used on Windows APIs. You can format void pointers, and even some undefined behaviors. So that's actually very good. So I think this is almost all that I wanted to show. So please let me know if you find this new introduction of tools useful. If there is anything that you think would be valuable to add as a tools. I think this is something neat, and I hope to expand on it even as we go with more tools and with more things that I have in mind. I don't want to disclose them yet because they're not really fully, I'm not really 100% sure how I'm going to make them, but once I have a clear idea, you will for sure know. So please let me know in the comments what you think, or on Discord. We have a Discord where you can just go join and post any question regarding Sane C++ libraries or even other projects that have a similar spirit. I think I've been trying to gather people that are feeling the same as I feel regarding the state of how C++ programs should be made and how we should be concentrating more on getting actual problems solved instead of doing a language debate. I hope you enjoyed this video and make sure to check out Sane C++ libraries, have fun, and see you next time.